Hello everyone, we are Abhishek, Yuxel, Suvam and myself Kushal. We are group 16 and have chosen to analyze Ludwig as part of our project for this course software architecture. To start with, let's see what is Ludwig. Ludwig is a toolbox that allows to train and test deep learning models without the need to write code. As we already know, machine learning is one of the hottest topics currently in research. Following on this line, Uber has built this software on top of TensorFlow and also open sourced it. Ludwig is a standalone software. It doesn't require any connection to the cloud or the internet. Let's see why it is required. Deep learning models have proven to be highly effective at performing a wide variety of machine learning tasks, be it in computer vision, speech, or language. Since building models have now also become a requirement for domains not related to computer science, the domain experts without much knowledge in deep learning find it difficult to build them. Now, this is where Ludwig comes into play. It eases out the model building process. Let's see how Ludwig works. Ludwig follows a simple ECD architecture, meaning encoder, combiner, decoder. As we can see, we have various types of inputs followed by encoder, combiner, and decoder. Encoder and decoder here can be convolutional network, recurrent neural network, and many more. Well, I'm not digging deeper into deep learning now. This architecture is well planned to accommodate most deep learning concepts. Here's an example of a YAML file which is given as input to Ludwig. As we see, there exists three main paths: input features, output features, and training. Here, stacked CNN has been mentioned as the encoder, which is followed by the details of the layers. Similarly, the type and the name of the outputs are mentioned. We pass this file as the input along with the path to the CSV file. Well, that's all. The model starts to train. We didn't code anything. The only thing we did was pass the inputs and the YAML file.
Okay, so now that we know what Ludwig is and what it does, we can move on to learning about how it works. Our aim now is to analyze Ludwig's architecture and try to better understand its functioning. So let's begin with a rundown of what goes on under Ludwig's hood. So the first step during runtime is to build a model. One of Ludwig's most notable innovations is its declarative approach to defining a model, which is done using a schema. So as shown earlier, the user can simply declare features of every component in the model, and the components starting right from the pre-processing to the training loop, etc. And these are all then dynamically built. And now moving on to the training and prediction pipelines. As shown in the image, the runtime process of the training and prediction pipelines themselves are not particularly different from that of other tools. And as you can see, the training phase consists of metadata collection, data processing, and model training. Similarly, the prediction phase uses the metadata, weights, and hyperparameters generated during the training phase to obtain predictions on the input data. However, as Ludwig is meant to allow for quick exploration of alternative models for the same data, it does additionally allow for caching of processed data into an HTF5 file, which then the user can use on other models. So now that we understand how Ludwig works, we can venture into its code structure. Ludwig being such a young open source project, the core development team has put considerable thought and effort into structuring Ludwig's codebase and streamlining Ludwig's development process. The figures shown here illustrates Ludwig's core and test module structures. And as we can see, Ludwig uses a very plain and simple readable structure that's meant to make it easy for contributors such as you and I to locate and modify code. Each of the submodules within the core module plays an important role in Ludwig's functioning. The main Ludwig module is responsible for integrating and running the other modules. Unsurprisingly, the data module deals with processing input data. Similarly, the aptly named features module contains functional and logical implementations for things like encoders and decoders and so on. The models module, on the other hand, is responsible for using these features to provide results to the post-processor unit. The utilities, or the utils module, as the name would suggest, is merely a collection of system utilities, such as math utilities, image utilities, and so on. And finally, the contribs module contains files from third-party integrations. Moving on to the other important module, the test module. It merely contains a set of coverage tests that have been provided by Ludwig's development team for use by contributors to test new additions to the codebase. So these tests primarily test interactions between Ludwig's modules and expose possible defects in their interfaces or interactions.
Now, let's imagine that the code base discussed so far works for a certain requirement and the developer is glad that his modifications to the code work successfully and merges the changes. Now another developer comes back to continue his work but finds out that his previously running code unfortunately fails. This might be because the other person wrongly modified certain dependencies used by this person to suit his needs. These kind of situations might lead to a serious damage to the system. This is where tests and code quality comes into picture. Ludwig gracefully integrates these checks in its CI pipeline. As can be seen, there are two most important checks. First, Deep Source's Python analyzer, which basically evaluates Ludwig's code base to ensure certain quality metrics are satisfied. For example, bugs, type check issues, performance issues, etc. On passing this check, it moves on to check if the code actually works with the modified changes by building it using Travis CI build platform. Remember the need for tests I mentioned a few moments ago? This is where these tests are done. Well, although it is important that the tests need to be done in a systematic order, that is, unit tests followed by integration tests and then functional tests, etc., it is quite odd that Ludwig directly jumps to perform only the integration tests. But from one of the issues in Ludwig's repo, we found out the reasoning behind this. To be precise, quoting Piero, Ludwig's architect cum maintainer's words, Ludwig, being a relatively young project, its current state or structure is expected to undergo alterations in the coming releases, and a more restrictive test suite containing extensive unit tests would only hamper the speed of development of the project. So this is why they are just focusing on the integration tests. But now enough about the quality and standards. What's currently up with Ludwig? Where are all the developers putting their coding skills into?
The hotspots of Ludwig will give us a chance to see where all the Ludwig developers currently working on. The hotspots of Ludwig can be inspected by investigating several things in Ludwig. Firstly, we can check the latest commits which are done on files and on each individual components. In this slide, latest commits on individual files can be seen. You see here which files have been changed the most, and red dots illustrate the changes. API.py, experiment, train, visualization, model.py can be given as an example of which are changed the most. The bubbles having lighter colors show the components they have. So here you see about 4 or 5 different components, and you see the red dots which contribute to the most. In this slide, we see how the latest commits are reflected on each individual component in this repository. This table is quantified version of the previous slide. Moreover, you can see here that the hottest component is the features component. All of the hotspots we have clarified previously have contributed to the roadmap of Ludwig. This roadmap illustrates the architectural blocks which are undergoing change right now. We can simply analyze this part into two different sections. Firstly, we say in this first report that the developers of Ludwig has clarified the roadmap for future release. These are 4 features they challenge themselves with: adding new encoders and decoders, time series decoding, adding new feature types, and pre-processing support. Secondly, we can check the merged pull requests and investigate the roadmap. In this slide, you can see the merged PRs, which will be functional in the next releases of Ludwig. Illustrating these features are adding audio data type, birth encoder, TF2 porting, and Horowat.